Hello and welcome, it's Ian here from Crack Maths, and in this video we are going to be looking through paper 3 for OCR foundation paper from Monday the 13th of November 2023. This is a calculator paper, so you are allowed your calculator, and yes, so let's begin. Here we go, we've got question 1 here, and question 1 says, for each letter in the box below, draw all the lines of symmetry. Okay, so for this first letter here, we're going to have a line of symmetry down the middle, because we could fold that over. 1 second. There. Here we go. We've got question 1 here. Okay, and then the next bit we're going to have is this C. So to do the C, I'm going to draw a line along there, because that's how it would reflect. And then lastly, what we've got is we've got this line, this shape here, which is going to have quite a few lines of symmetry actually. It's going to have one down here, and then it's going to have one across here. Okay, but then it's also going to have one that goes through this way, and we will have one that goes through this way as well. Okay, great. Right, part B we've got here, which is this shape is drawn using 4 quarter circles. Write down the order of rotational symmetry. Okay, so rotational symmetry is how many times you can spin it round and it gets back to the same place. Okay, so what I want to do is I'm just going to kind of draw this outline over this here. And what I can do here is if I just make a mark at this top one, what we can do is we can see how many times we can spin this round. You might be already able to see it, but what we can see is we can do it once, okay, and it looks the same, twice, and it looks the same, 3 times, and it looks the same, 4 times, and it looks the same. Okay, so this would have a rotational symmetry of order 4. Okay, right, let's have a look at part 2a. So question 2a says, in the number 34,752, the digit 4 represents 4,000. Write in words what digit 7 represents. So let's read that number out again. 34,752. Well, that equal 700 is what the 7 is. So write in words the digit the 7 represents. So this is going to be 7, S-E-V-E-N, 100. Okay, there we go. And part B says, write 8 million in figures. Okay, so 8 million is 8 with 6 zeros. Okay, right, let's get a look at the mark scheme. Here we go. So here we go, just check that that fits on. 1 second, let's shrink that a little bit. There we go. And so here we go, 6 correct lines drawn, 4, 700 and 8 million. Yeah, we are correct with all of those. Okay, right, so let me get this back up. Okay, here we go. And let's move on to the next question. 1 second, I just need to go do something. Take a look at this and I'll be right back. Okay, perfect. Right, let's now take a look at this question here. So this question here says, what type of numbers are 2, 3 and 5? Okay, well, circle one of the answers from the list. So what we have here is we have cube numbers, even numbers, odd numbers, prime numbers and square numbers. Right, well, the cube numbers are when we multiply numbers by themselves 3 times. Okay, so what we're looking at with cube numbers is we're looking at 1 cubed, which is 1, 2 cubed, which is 2 times 2 times 2, which gives us 8, 3 cubed, which is 3 times 3 times 3, which gives us 27. And, well, we can see that these aren't the cube numbers. Okay, even numbers, well, even numbers are 2, 4, 6, 8. I can see that's not them. Odd numbers are 1, 3, 5, so the 2 eliminates that. I actually do know that these are prime numbers. Prime numbers are numbers with only 2 factors, so numbers that can only be divided by themselves and 1. So that's what these all are. But we can also prove that they're not square numbers, because square numbers are the result of multiplying a number by itself. So if we think about 1 squared, that's 1 times 1, which is 1. 2 squared equals 2 times 2, which is 4. And so already we can see that the numbers 2, 3, 5 are not the same as the square numbers. Okay, right. Let's have a look at these next 5 tiles. So these are 5 tiles. We've got 2, 3, 3, 5 and blank. Arrange the 5 tiles to make a calculation with the answer 3. Okay, right. So what I'm going to do is, I think if I look at these, I can see that these make 5. This is 5. So what I'm going to do is I'm going to do 2 add 3, which equals 5. Okay, if I think about that like that. And then if I take away 5 from there, I'm back to 0, because 5 take away 5 is 0. And then I'm going to add the 3. Okay, so there's probably multiple ways of doing this, but this is the way that I'm going to go for. So we've got 2, add 3, take away... Oh, no, that doesn't work. Oh, it doesn't fit. Oh, okay, that's interesting. What does it mean? Arrange these 5 tiles in a calculation with the answer 3. So that wasn't the way. Let's have another go. Oh, 1 second. We've got to use this minus as well. Right, so that's not what it meant. I can put these together. So I want to make... Right, okay, so I can see what I want to do. I want to have 35... 1 second. 35 take away 32. So here we go. So we're going to use the 3 and the 5 here, and then we're going to use the 3 and the 2 here. Right. Okay, part 2. Write down a multiple of 8 that can be made using the 5 tiles. Okay. So, do I have 2 of the 5 tiles? Right. So what we're going to do is it's going to have to end in the 2, because the multiple of 8 has to be even. Well, I know that 32 is in the 8 times table, so I can use 32 here. Okay, great. Right, let's have a look here at the answers and see if they are correct. So here we go. We've got prime numbers. Yep, 35 take away 32, 32. And then we're on to question 4, which we'll go on to the next page for. Okay, so here we go. Right, question 4, here, bring that up. Question 4 says, a fair-sided spinner has 5 sides numbered 1, 2, 3, 4 and 5. Write down the probability that the spinner on landing on 2. Okay, so there's 5 sides, one of them is a 2, so the probability will be 1 out of 5. Okay, that's what we're looking at there. If there's 5 sides, 5 options, one of them's a 2, the probability will be 1 out of 5. Right, part 2. Write down the probability of the spinner not landing on 2. So that means, well, let's look how many options are not 2 even. We've got 1, 2, 3, 4. So we've got 4 options out of 5, which are not 2. Okay, so the probability of it not landing on 2 is 4 out of 5. Okay, part B. Write down the outcome for the spinner that has a probability of 0. So write down an outcome for the spinner that has a probability of 0. And that could be the spinner lands on 6. Okay, it's impossible for it to land on 6 because there's no side labelled 6. So there we go. That is our probability outcome with a probability of 0. Right, let's have a look at question 5. So question 5 says, use one of the symbols Okay, greater than, less than, or equal to make each statement true. Okay, so let's have a look here. So 0 minus 2. Well, 0 is a larger number than minus 2 because minus 2 isn't yet at 0. So we put the symbol this way because I don't know if you remember it, but the crocodile goes after the big food. That's how they think about this. So if you think about that as your crocodile, so the crocodile's going after the 0 as opposed to the negative 2. This one here, 3.5, 7 over 2. Right, well, 7 over 2 is actually equal to 3.5, but this is the calculator paper, so let me show you that on here. I'll get the calculator out. So remember, that line means divide. So if I do 7 divided by 2, that equals 3.5. So what I can see is that these two things are equal. So here we go. They are both equal, so I'll put the equals sign there. Okay, right, let's have a look at question 6. Question 6 says, a family buys a television for £599. They pay a deposit of £119. Then they pay the rest of the cost in 12 equal payments. How much is each payment? Okay, so we're starting off with £599 and we're taking away £119. So I'm going to be lazy and use the calculator for this. So what we have is 599 take away 119, and that equals 480. Okay, so 12 payments has to cover that cost here. So I'll say 12 payments equals 480, and then we want to find out one payment. So to find out one payment, we've got to divide this by 12. So one payment will equal the total divided by 12. Okay, so let's now do 480 divided by 12, and that will be 40. Okay, so each of the 12 payments will be £40. So there we go. We can write that there. Right, let's now take a look at the mark scheme to check that those questions are correct, and then we will move on. So here we go. We've got 1/5, or you could have put 0.2 or 20% because they're all the same. We've got 4/5 or 0.8 or 80% because they're all the same. An example with a probability that has 0, so they've put the example that we used, getting 6. And then we've got the greater than symbol, the equal symbol, and 40. Perfect. So they were all correct. Excellent. Right, let's have a move on. Right, here we go. Question 7a. Write this ratio in its simplest form. 4 centimetres to 8 millimetres. Okay, right, so let's see this. So this would be the same as 2 centimetres. Oh, I was thinking of the eye. 2 centimetres. Sorry, I can't be bothered to write centimetres. So this would be the same as 2 cm to 4 millimetres. Okay, that would be 2 centimetres to 4 millimetres. And then we can change that again. We can go 1 centimetre to 2 millimetres. Okay, so here we go. 1 cm to 2 mm. Now, I'm presuming that's what they want, okay, because they've given us quite a lot of space to write that. The other option of the thing that they could want is to convert them both into the same unit. But I don't think that's what they want because they've put the word centimetres and millimetres there and they've given us this amount of space. Part B says, the ratio 4 to 5 can be written in the form 1 to n. Find the value of n. So if we've got 4 to 5 here, and we want to make this go to 1, we're going to divide this by 4. So we've got to divide this by 4 as well. Well, 4 divided by 4 is 1. 5 divided by 4, well, remember this is a calculator paper, so we can use the calculator for that. So 5 divided by 4 is equal to 1.25. Okay, so if we're writing 4 to 5 in the ratio 1 to n, the value of n would be 1.25. Okay, great. Let's have a look at question 8. So question 8 says, let me get rid of the calculator. It's a little bit in the way there. So question 8 says, simplify 4a plus 2a plus 1a It doesn't say 1a there, but if you see an a by itself, that means 1a. So if I've got 4a plus 2a, that takes me up to 6a. And then if I've got another a, that means that there's 7a there. So I'm going to write 7a. Part 2 says we've got 2x minus 3y minus 3x plus 4. So here what we do is we collect the like terms. So that's going to be the 2x and the minus 3x there. And so what we can do, it is the calculator paper. So let's just think about this. We've got 2x, we can't put the x in obviously, but 2x minus 3x, so 2 minus 3. So that's minus 1x that we've got there. So I'm going to write that down. So we've got minus 1x, or we can just call it minus x. And then the y's and the 4, we can't really do anything with that, so we just have to write them again as they are. So we've got minus x minus 3y plus 4. Okay, right. Let's look at part B. So part B says p minus 5 equals negative 4. Right, so what we've got to do here is we've got to get rid of this negative 5. Now the way that we get rid of a negative 5 is by adding 5 to both sides. So I'm going to add 5 to this side and add 5 to this side. Remember, you only add the like to like. So this 5 is being added to this minus 5. Okay, so minus 5 add 5 makes 0. Well, that's why I chose 5. So this side is just left with p. Now here what we have is we've got minus 4 plus 5. So here we go. Because this is a calculator paper, we can do that on here. So let's get minus 4. So here we go. We've got minus 4 there. And then let's add 5 to that. Okay, so minus 4 add 5 takes us to 1. So for here we'll get p equals 1. Right, let's have a quick look to check if those answers are correct, and then we'll move on. So here we go. 5 to 1. Okay, so right, I was wrong with question 1. Well, I was right in my suspicions that they wanted something different, but they did want us to convert the units. Okay, so we'll mark the rest of these and then we'll go back through that. So we've got 5 to 1 here. Here we've got 1.25, which is correct. 7a, we got that correct. Minus x plus 4 minus 3y. We got that right as well. And then p is equal to 1. We got that correct too. So let's look back at that other question here. So this one here, they wanted us to have it in its same units, okay? So let me clear this information here and let's rewrite that. So we've got 4 centimeters to 8 millimeters. Okay, now 4 centimeters, well, we know that 1 centimeter equals 10 millimeters. Okay, so what we're going to have to do here is we're going to have to convert this into millimeters. So if 1 centimeter equals 10 millimeters, what we can do is we can say that 4 centimeters equals 40 millimeters. Okay, so here we go, because we can times that by 4 and we can times that by 4. So now what I can do is I can replace the 4 centimeters with the 40 millimeters. So here we go. Let's replace that here. So we've got 40 millimeters here and we've got 8 millimeters here. Now what we need to do is we need to simplify the ratio, which we can do in the same way that we did before. So we could say that's 20 to 4. We could say that is 10 to 2. And then that simplifies again to 5 to 1, which was the answer that they had. So here we go. So 5 to 1 is the answer for that. Okay, right. Let's have a look at the next paper and then we'll move on. So insert 1 pair of brackets into each calculation to make it correct. Right, so 15 divided by 7 minus 2 equals 3. Well, I know that 15 divided by 7 can't be done nicely. It just doesn't work because it wouldn't give an answer like 3. So what I'm going to do is I'm going to test the brackets around the 7 minus 2. Okay, so what I've got here is 7 minus 2 is 5. So then we'd do 15 divided by 5, and that does give us 3. So that one's absolutely fine. This next one here, we've got 26. So I can see here, actually, this one's a bit tricky. So we need to get So I first of all initially thought, oh, hang on a second, if we do this, we'll get a 6 here, so that will be good. But this bit only gives us 10. So if we did that, that would only give us 16. So that's no good. So they've got to be somewhere else. So I think I can see where they're going to be. They're going to be round this section here. Okay. Oh, 1 sec. Oh, sorry about that. I didn't mean to do that. Right, so they're going to be round this section here, because what we're going to get is we're going to get 5 times 2, which is 10, and then add the 3, which is 13, and then 13 times 2 equals 26. Now, actually, with anything to do with BODMAS, we can test that we've got that correct on our calculator. If I just change to the scientific mode, let me move it over here. So let's just check that that works, because if you've got your BODMAS correct, then that means that the calculator should do exactly what you want. So we've got 5 times 2 plus 3, close the bracket, times 2, and if this is correct, this will equal 26. And it is correct. Perfect. So there we go. Let me turn that back into a basic calculator so I can hide it and move that over here. Right, 10a. For 10a, we've got to factorise 5x minus 20. So factorise means to find the factor of both of these things that we can divide both these things by. So 5x and negative 20 can both be divided by 5, because I know that 5 times 1 makes 5 and 5 times 4 makes 20. So here we go. I'm going to put a 5 on the outside of a bracket here, and then inside the bracket I'm going to put x minus 4. Okay, and just to confirm that, this is our way of showing the bracket says that everything inside the bracket has to be multiplied by what's on the outside of the bracket. So we get 5 times x and we get 5 times negative 4. Okay, and we can check the 5 times negative 4 if we want over here. So let's have a look. 5 times 4 but negative equals minus 20. Yeah, so we've got our negative numbers correct. Right, this part B, best write that here, 5x minus 4. This part B, what we have is 14x plus 7x squared. So this time I can see that they're both divisible by 7, so I'm going to put a 7 on the outside of my bracket, and they're also both divisible by x, okay? Because 14 times x makes 14x, x squared, well, x times x makes x squared, so I'm putting 7x on the outside, and then what do I multiply 7x by to get 14x? Well, that is just 2, okay? And then what do I multiply 7x squared by to get 7x? What do I multiply 7x by to get 7x squared? Well, that is going to be x. So this is the answer here. And let's just double check these things. 7x times 2 is 14x. 7x times x makes 7x squared. Yeah, so I'm happy with this. And then we can, oh, I'm not writing it correct though. We can go on to mark this. 7x, 2 plus x. Right, let's go over to the mark scheme and check that this is correct. So let's have a look here. So we had, let's see what were the first things that we had in here. Yeah, we got those BODMAS things correct, but we knew that because we tested that on our calculator. Yeah, x minus 4, 7x, 2 plus x. Great. Okay, let's have a look at the next page. So here we go. In question 11, what we have is we've got Gabby records the number of times a biased 6-sided dice lands on each of its numbers. Complete the table to show the relative frequencies. Okay, right. So the relative frequency is just the probability at that time. So, let's have 1 second. So, number on the dice, 1. Frequency, 10. Okay, so the relative frequency is the probability that it lands on that number. So what it means is, currently, the probability that it lands on these is how many times it landed on these out of the total frequency. So the first thing we need to do is work out what the total frequency is for how many times she rolled this dice. So I'm going to get my calculator out here and add these numbers together. So we've got 10 times it landed on 1, add 21 times for it landing on 2, add 7 times for it landing on 3, add 4 times for it landing on 4, add 3 times for it landing on 5, and add 5 times for it landing on 6. So altogether, if we add these together, that equals 50. Okay, so the total frequency for the number of rolls was 50. So now we can find the relative frequency, which is essentially just the probability that it lands on that number. So it landed on 1 10 times out of 50. Okay, so 10 times out of 50 is going to be, well, the probability for that, if we want 10 times out of 50, what we're going to do is we will do 10 divided by 50. So there we go, 10 divided by 50 is 0.2. And then for landing on 2, we've got 21 times out of 50. So we'll do 21 divided by 50. And that equals 0.42. For number 3, it's 7 times out of 50. So we'll do 7 divided by 50. And that is 0.14. And then for 4, we've got 4 times out of 50. So 4 divided by 50. And that is 0.8. So here we go. No, 0.08. Sorry, very big difference there. 0.8 is very likely. 0.08 is very unlikely. Okay, right. So here we go. That's that part done. Now let's have a look at part B. Use Gabby's results to estimate the probability that the spinner lands on 5 or 6. Okay, so if it landing on 5 or 6 means it's increasing the probability because we're increasing the options of things that it can do. So if you see that word or, it means that we add the probabilities together. So the probability that it lands on a 5 is 0.06, and then the probability that it lands on a 6 is 0.10. Okay, so we're just going to add these two things together. That is going to be 0.16, but you could do that on your calculator as well, because this is the calculator test. But that is that for this question. Okay, and that's that for that page. So let's quickly mark these to check that everything is going well. So here we go. Yeah, we've got 0.2, 0.42, 0.14, 0.08, great, and 0.16, wonderful. Nothing went wrong there. Okay, right. Let's move on. The next question we've got here is decrease 480 by 20%. Right, okay, well, if you think about it, in life we always start with 100%, and then if we take 20% away from that, we are looking for 80%. Okay, so to decrease something by 20% means to find 80%. If we want to find 80%, we just do 80 divided by 100 to convert it into a decimal, and that will give us 0.8. Okay, and now what we do is this is our decimal equivalent percentage multiplier. So now whatever we multiply by 0.8 will give us a 20% decrease or 80% of its value. So now we just need to do 480 multiplied by 0.8. And I'm going to get the calculator out for that, because that is something that is much easier to do with a calculator. So here we go, 480 multiplied by 0.8. There we go, and that's 384. So there we go, 384. And now we can move on to part B. So part B says, Alex buys a new phone with a 10.5 gigabytes of data. This is 40% more data than on Alex's old phone. Work out the amount of data Alex had on his old phone. So if this was a 40% increase, if we think about his old phone having 100% data, if we add 40% to that, that gives us 140%, okay? So Alex's new phone has 140% of the data of his old phone. Okay, now if you want to find 140% of something, what we do is we do 140 divided by 100, which equals 1.4. Now this tells us that anything multiplied by 1.4 has been increased by 40%. So we can think about this as a sum, okay? So we can think of Alex's old phone, multiplied by 1.4, okay, gives 10.5, okay? So here we go. So Alex's old phone, increase the data by 40%, and then that data will now equal 10.5. So we just need to rearrange this expression, okay? So this is a reverse calculation that we want to do. Whenever you have two numbers that multiply together to give a product, the product divided by either of these numbers gives the other one. So all I need to do now is do 10.5 divided by 1.4, and this will give me the amount of data on the old phone. So again, this is a calculator paper, so I'm going to do this with a calculator. So 10.5 divided by 1.4. So here we go, and that is 7.5, and that is a nice answer, which makes me feel like we've got it correct. Okay, right, let's move that off the screen, and let's have a look at question 13. So question 13 says, a student has a pencil case containing 60 pencils. 1/4 of the pencils are red, and 2/5 of the red pencils need sharpening. Work out how many of the red pencils need sharpening. Okay, so let's first of all work out 1/4 of the pencils. So we know that all the pencils are 60, so we want to do 1/4 of 60, okay? Now, if you want to find 1/4 of something, if we think about a cake, if we're dividing it into quarters, we're dividing it into 4. So to find 1/4 of 60, we do 60 divided by 4, okay? So here we go, let's do that on the calculator. So we've got here 60 divided by 4, and that equals 15, okay? So we now know that there are 15 red pencils, okay? So we're then told that 2/5 of the red pencils need sharpening. So the way that we go about finding 2/5 is we find out what 1/5 is by dividing by 5, and then once we know what 1/5 is, we're going to multiply that by 2. So let's first of all find 1/5 of 15, okay? So 1/5 of 15 is 15 divided by 5. Okay, 15 divided by 5 is 3. And then we want 2/5. Well, 2/5 is going to be 3 times 2, because we've got 1/5, which is, so we know that 1/5 equals 3. So 2/5 is 2 lots of that, which will be 6. So here we go, we can get our answer there. So there will be 6 pencils that need sharpening. Right, let's take a look at the mark scheme to see if they're correct, and then we will move on. So we have got 384, yep, 7.5, yep, and 6 here, correct. Okay, wonderful. Right, let us go back to the paper and then find out what's on the next page. So here we go, we've got question 14 here, and it says, show that the formula V equals U plus AT can be rearranged to A equals V minus U all divided by T. Okay, right. So let's start off by writing it down. So we've got V equals U plus AT. Right, well the first thing that we can do is we can get rid of this U because that's not very closely attached to the A. So all we need to do is we just need to take away the U from both sides of this equation. So we're going to end up with V take away U equals AT. Okay, now I'm going to rewrite that over here as AT equals V minus U. I'm allowed to do that because the equal sign just means that these things are the same. Okay, so AT has the same value as V minus U. So I can write AT equals V minus U, or I can write V minus U equals AT. Now what I've got to do is I want A by itself, but currently A is being multiplied by T. So I need to divide both sides by T. Okay, and that's going to leave me with A equals V minus U. And then, as we said, as with the answer, over T. Because this means what this means is the value of this, so whatever this value is, divided by t. Okay, so there we go, we've shown that there, and that is very useful. Okay, right, let's have a look at part B. So part B says, use this formula, A equals v minus u over t, to find the acceleration, a meters per second squared, when a particle takes 4 seconds to increase from an initial velocity of 3 to a final velocity of 9. Wow. Okay, so do they... Interesting. I don't often do OCR, but I didn't realise they expected you to know what these letters stand for. So you might know what these letters stand for from physics, but in these letters here, we've got V is equal to the final velocity. That's what that letter stands for. And U equals the initial velocity. Okay, right, so let's put this information in. So we know that A equals the final velocity, which I believe we've been told is 9. Take away the initial velocity, which is 3, all divided by the time that takes, that's the t, which is 4. So here we go, A equals 9 take away 3 over 4. Well, 9 take away 3 is 6. So we're looking at 6 over 4. I know what that is, but we'll use the calculator just because it's here. Okay, 6 divided by 4 is equal to 1.5. So A equals 1.5 meters per second squared. Right, let's take a look here and to see if we got these correct. Right, there we go. They just want that. That's funny in the mark scheme. They're just saying that it's shown. So that's the importance of working. Okay, the mark is for seeing this. Okay, for seeing V minus U equals AT. So that's where they've got the mark for. Okay, and then for this one, 1.5 or equivalent. So that is both fine. Right, let's move on. Here we go. Question 15. So a regular polygon is being constructed inside a circle with centre O. Part of the construction is shown in the diagram below. So here we go. We can see that we've got segments with 20 degrees here, 20 degrees here, 20 degrees here. And this says, give a reason why OA equals OB. Okay, well, if this is a circle and O is the centre, OA is the radius because that's the distance from the centre to the outside, and OB must also be the radius, okay, because that's the distance from the centre to the outside. Now a circle doesn't have multiple radiuses, it's just got one radius. So give a reason why OA equals OB, and that is because they are both the radius. They are both the radius. Okay, here we go. So now, write down a mathematical name for triangle OAB. Well, the name for a triangle with two sides the same is an isosceles. I've spelt this wrong. Oh my gosh, I've forgotten how to spell isosceles. Isosceles? I think like that. I think that's it there. So isosceles. Because maybe, I might have it wrong. The C might go there. But we'll find out when we look at the answers. They won't pin you down for that. Right. The regular polygon is completed. Work out the sum of the interior angles of the regular polygon. Okay, right. So, well, we need to work out, well, there's two steps to this. One, we're going to have to work out the size of these angles. Okay, so that we could work out the size of one interior angle here. And then what we're going to do is, if we know that each of these angles are 20, we've got to work out how many lots of 20 will complete the circle as a 360 degrees. So actually, let's start off by doing that bit first. So if we do 360 degrees divided by 20 degrees, that will tell us how many of these triangles that there are. So we can do that here. So let's have a look. We've got 360 divided by 20, and that equals 18. So that is 18 segments. So we've got 18 triangles there. And now what we need to do is we need to work out what this angle is here. Well, angles inside a triangle add up to 180. Okay, so if these two angles here are the same, if we call them the same, this angle's 20. So if we take away the 20, we're left with 160. Now that means that these two angles here must add up to 160. Now as they're the same, we can just do 160 divided by 2. And that gives me 80. Okay, so that gives me 80. So that's 80 and that's 80. But what we actually can do is if we think about this angle here, or this complete angle over here, let's focus on this one. So if we look at this complete angle here, this complete angle would be 160. And if there are 20 triangles, that means there's 20 corners. If there's 18 triangles, that means there's 18 corners like this. So there's 18 of these 160 degree angles. So what we can do is we can do 160 multiplied by 18, and that will give us the total sum of the interior angles in the regular polygon. So we've got 160 multiplied by 18, and that equals 2,880. Okay, so I'll write that down here. So here we go, we've got 2,880. All right, let's quickly mark these and then we can move on to the next page. Okay, so yeah, 2 equal radii. Radius is fine. Must refer to the radius is the main thing. Isosceles is fine, and we spelt it correctly, but over here they tell us that they do condone poor spelling, so that is okay. And then here we've got 2,880, and that was correct. Okay, right, so let's move on. So in question 16, what we have here is it says, Dev and Emma share some money in the ratio 2:3. Okay, Dev says, I get 2/3 of the money. What mistake has Dev made? Give the fraction Dev actually receives. So Dev has just assumed that there's 3 parts to this ratio and he gets 2 of them. But that's not true, because actually what we've got is we've got Dev and Emma. If we've got Dev and Emma here, Dev is getting 2 parts and Emma is getting 3 parts. So actually altogether there's 5 parts to this ratio, and he is getting 2 of them. So he's actually getting 2/5. Okay, so the mistake he's made is he has not realised how many parts to the ratio there are. Ratio there. Okay, right. So part B says Dev receives £100. Work out how much money Dev and Emma shared between them. Okay, so this is useful. So we know up here that Dev's 2 parts make £100. Now, if 2 parts equals £100, that means that 1 part will equal £50. Okay, so each of these boxes are 50, 50, 50, 50, 50, 50. Okay, so we can then just add those up, or we can think about it as being 5 parts and just multiply this by 5. Okay, well, 5 times 5 is 25. Add the 0 is 250. So Dev and Emma shared £250 between them. Right, so here we go. I will write that here, £250. Okay, right, let's quickly mark that to check that nothing went wrong. So here we go. Correct comment implying addition or 5 parts and 2/5. Yep, £250. Perfect. Right, let's have a look at the next one. So question 17a says, work out the perimeter of this rectangle. So what we've got here is we've got 3 and 11, okay? and the perimeter is the distance around the outside. So what I need to do is I just need to add the extra dimensions on. Because it's a rectangle, opposite sides are the same. And then if we think about the perimeter, it's this here, so this 11, add this 3, add this 11, add this 3. So we've got 11, add 3, add 11, add 3. I can do this without the calculator actually. 11 add 3 is 14. So 2 lots of 14 makes 28. So it'll be 28 centimetres. Oh, they've given us the centimetres there anyway. Very kind of them. Okay, right, now let's have a look at this next one. So this next question says, Finley draws a rectangle and says the perimeter is 20 centimetres and the length is 10 centimetres. Can Finley be correct? Show how you decide. Okay, right, so let's have a look. So if we had a rectangle here and the length was 10 centimetres, that would make that 10 centimetres. And then we don't know what these are. But actually, no, because the perimeter is all of these things added together. So that would be 10, add 10, add x, and that would equal 20, add, well, 2x, okay, which means we're already at 20, so it won't work because if you didn't have any width to the rectangle, because the only way this would work is if this was 0, if you didn't have any width to the rectangle, we wouldn't call it a rectangle, we would just call it a line, okay, so no, because if the length is 10, length is 10, 2 times 10 equals 20, which means width would be 0. Okay, that's the problem there, width would be 0. Okay, great. Right, let's have a look at, oh no, well let's mark that, let's see what they wrote down and then move on. So here we go, yeah, 28 there, no, and they want to see that 10 add 10 equals 20, and a recognition that height is 0 isn't okay. Okay, right, so, right, let's have a look at part, oh no, that's that page done, wasn't it? Let's have a look at question 18. So question 18 says, Nina invests £540 at a simple interest rate of 2% per year. Kareem invests £540 at a compound interest rate of 2% per year. Work out the difference in value between the two investments at the end of 5 years. So simple interest suggests that we just work out 2% of this and then we times that by 5 and add it on, and that is how much it will be worth at the end. So let's first of all do that. So if we want to find 2% of something, what we do is we do 2% divided by 100 equals 0.02, and then anything we multiply by 0.02 will give us 2% of that. So let's just do that there. So we've got 540 times 0.02, and let's see what that gives us. We can do that on the calculator. So here we go. So 540 times 0.02 equals 10.8. There we go, 10.8. That's not much. Okay, anyway, so that's how much money he'll receive a year. Okay, so if £10 80 pence he'll get per year. He's going to get that for 5 years, so we'll do 10.8 times 5, find out what that equals. So let's multiply this by 5. 10.8. So that's £54. Okay, so at the end of the 5 years, he will have made an extra £54. So we can add that to the 540. Here we go. And that'll be 594. So at the end of it all, Nina has £594. Okay, right. So let me move the calculator away because that's that bit done. Now, compound interest is a little bit different to simple interest. It's when you're finding the percentage of the new amount that includes the interest from the previous year. So what we have to do here is we have to think about how to increase by 2%. So if I've got 100% as my starting value and I want to add 2%, that means I'm looking at 102%. So to find 102% of something, what we do is we do 102% divided by 100, and that gives us 1.02. So now anything we multiply by 1.02 will be increased by 2%. So what we can do here is we can think about £540 here, £540. Okay, if we times that by 1.02, if we do that once, that will increase it by 2% for 1 year. And then if we do this again, that will be increasing it by 2% for a second year. Okay, but what we're going to be doing is when we times it by this again, we're increasing this new value here by the 2%. So then we'll do it again, and that'll increase this value by 2%. Then we'll do it again, and that'll increase this value here by 2%. And then we do it once more for the 5th year, and that'll increase the last value by 2%. So what we get here is we've got 540 times 1.02 5 times. Now, to do it like that, that's going to take quite a long time to type into the calculator. So what I can do instead is I can do 540 times 1.02 to the power of 5, because the power of 5 means multiplying it by this 5 times, and that's exactly what we want to achieve. So let's change to the scientific calculator. Okay, and then if I put this here, we want 540 multiplied by 1.02 and then to the power of 5. So there we go, and that's going to equal 596 point, I'm going to call that 0.21 because we're looking at money. Okay, so we don't really want to go beyond pence. So there we go. I'm going to remove that here, and then let me turn that back into a basic calculator. Okay, so here we go. We've got the second one. We've got £596 and 21 pence. Okay, so what was the other one? £594. It's not a big difference actually, is it, at the end of 5 years? So work out the difference in the value between the two investments. So we'll have to do 596.21 take away 594. Okay, and that's just going to be £2 and 21 pence. So not a huge difference at that level. Okay, let's have a go at this, and let's have a go at marking these questions to see if they're correct. So here we go. They've gone for £2.20 with correct working. That's interesting. I wonder why they went for £2.20. Did I round that incorrectly? Let me just get out that calculator again. I did round that incorrectly. I looked at this 6 rather than this 3, and then I rounded it up. So this would have just been £2.20. Right. So there we go. £2.20. I can change that on my answer. So there we go. And then change that there. Okay, right. Let us continue. So here we go. Right, move that out of the way. Get the paper back up. And then let's move over here. Right. Question 19. Beth completes some jigsaw puzzles and records the following information: the number of pieces in the jigsaw puzzle, the time taken to complete the jigsaw puzzle in minutes. Beth shows this information in a scattergram. Time taken to complete the jigsaw puzzle. Okay. Number of jigsaw puzzle pieces. Right, I can see this. Okay, Beth completes 2 more jigsaw puzzles. A 3,000 piece jigsaw puzzle, which takes 460 minutes, and a 1,300 piece jigsaw puzzle taking 320 minutes. Show this information on the scattergram. Okay, so let's have a look. We've got a 3,000 piece jigsaw puzzle, 460 minutes. Right, so what I can see is we've got 5 squares, and they represent 100. Okay, so if I divide that by 5 to get 1 square, 100 divided by 5 is 20. So I can see each square here is worth 20. So if I'm at 3,000 and I want to find 460, I'm going to go up to 400 and then I'm going to go up 3 squares. So there we go. So that's got to be there. And then this next one, we've got a 1,300 piece jigsaw puzzle that took 320 minutes. So 1,300. Right, well this is a square for every 100 I can see because there's 10 squares going up the 1,000. So 1,300 and we want to get to 320. So up here and there we go. So we have now shown that information on the scattergram. Okay, and let's have a look here. Describe the correlation on the scatter graph. Well, the correlation on the scatter graph is going to be positive correlation because they're both going up together. Part B says, one of Beth's jigsaw puzzles was described as the most difficult jigsaw puzzle you will ever try. Circle the most likely jigsaw puzzle on the scatter diagram. Give your reason for that. So, I think it is this one here because it took the longest but it took the longest amount of time without having the most pieces. Okay, so this is the one I think was the most difficult. Okay, so there we go. Let's write that down there. So give your reason why. Took the longest without having the most pieces. Okay, great. Right, let's have a look at the next one. So, part C. So what we've got here is we've got draw the line of best fit on the diagram. Okay, so let's go back to the diagram and draw our line of best fit. I'll use a different colour for this. Here we go. So the line of best fit should go through the data. Okay, it's always tempting to stretch this line beyond the data, but you actually shouldn't do it because you only ever know about the data values that you have. So it could be that outside of this range, the correlation doesn't continue. So that's why I've drawn it like that. The other thing you should know is you shouldn't stretch it, you shouldn't force it to 0. That's also very bad. Right, let's have a look at the next question again. So, use your line of best fit to estimate how many pieces are in a jigsaw puzzle that takes Beth 500 minutes to complete. Okay, so 500 minutes is here. And then, so you need to draw these lines on because that's what they want to see. So draw to here and then draw down to here. Oh, it's quite a messy line. You should use a ruler. And I'm going to say that this is 3,000 and 100, 200, 300. It looks like 3,350 to me. So I'm going to write that down. There's going to be a leniency with this. But there we go. D. Explain why Beth should not use her scatter diagram to estimate how long it will take to complete a jigsaw puzzle using 8,000 pieces. Well, the reason for that is because she's only got experience of up to 4,500. So she doesn't really know. It could get exponentially harder as soon as you start getting more and more pieces. Or it could get easier, who knows? But the answer to that is she hasn't got any experience. With puzzles beyond 4,500 pieces. And then the mathematical thing that they might want you to say is outside the data range. Outside the data range. Okay, great. Right, let's mark this scatter graph question. So here we go. Let's go here. So what we have is right, points plotted correctly, positive correlation. We've circled the outlier, and the jigsaw took a long time for a smaller number of pieces. Yep. Line of best fit drawn. Their line used to give the number for 500 minutes. They haven't actually given us the leniency. Oh yeah, here we go. It says maybe 3,300 or 3,400. So between them is what we've got. And here we go, 8,000 pieces is beyond the given data. This trend pattern may not continue. So yep, that is the same as we said, but just in a different way. Right, let's have a look at the next one. So this question here, oh, it's a penny farthing. So the diagram shows a penny farthing bicycle. The diameter of the large wheel is 130 centimetres. The diameter of the small wheel is 46 centimetres. On a short journey, the large wheel makes exactly 69 rotations. The smaller wheel also makes an exact number of rotations. Work out the number of rotations. Oh my gosh. Work out the number of rotations made by the smaller wheel. Okay, right. So this is a circle question, really. So what we've got to do is we need to work out how far, if this wheel was rotating, we need to work out the circumference. Well, first things first, we need to work out the circumference for both of these circles, okay? Once we've got the circumference for both of these circles, we can then work out how far 69 rotations of the large wheel actually takes you, okay? So that's what we're going to be doing. So work out how far 69 rotations of the large wheel takes you, and then we can convert that into rotations for the smaller wheel. So the circumference of a circle is worked out by doing pi times diameter. So let's do the big one first. Large equals 130 times pi. The small equals 46 times pi. Okay, actually I'm going to leave this in terms of pi for as long as possible, because once we use pi, the number's going to be a bit awkward, okay? So it's best to keep our exact values for as long as we can. So on a short journey, the large wheel makes exactly 69 rotations. So we need to do 69 times 130 pi, okay? And that's going to tell us how many centimetres it travelled, okay? So what I'm going to do is I'm going to get the calculator out, and I'm going to do that here. So 69 times 130, okay, and that is 8,000, and that equals 8,970 pi. Okay, just out of interest, just so you know, when we're multiplying that by pi, it's like multiplying it by 3.14. So that is roughly this many centimetres, but I don't want to use that at this stage because it's going to make my question inaccurate. Okay, so let's move that out here. So we know that the distance is 870 pi. Okay, so we know that total distance equals 8,970 pi. Okay, now let's look at this small circle. So the small circle, so one rotation of the small circle is 46 pi, okay? Because that's the circumference of that small circle. One rotation will be 46 pi. So we want to find out how many rotations take us up to 8,970 pi. This is what we want to do. So we want to know what are we multiplying 46 pi by to get to 8,970 pi. So that's what we're trying to do. This is the calculation that we want to do. We want to do 46 pi, sorry. 46 pi multiplied by something equals 8,970 pi. So what we need to do is we're going to need to work out that something will equal 8,970 pi divided by 46 pi. Okay, right, now what we can do here is we can instantly just cancel out these pi's, because pi divided by pi is 1. And so all we need to do is we need to do 8,970 divided by 46. So let's get out the calculator for that. So we're looking for 8,970 divided by 46. And that's going to be 195. So there we go. So there we go. And that is an exact number. So that's very good. So that means we've got it correct. So 195 rotations. Okay, wonderful. Right, let's check that with the answer scheme to see if we are on track. And then, yeah, there we go, 195. Perfect. Right, so next, here we go. Let's have a look at question 21. So question 21 says, the graph shows the value of sunscreen products sold in a shop for each quarter from quarter 1 of 2021 to quarter 4 of 2023. Make one comment about the annual variation shown in this graph. Okay. Well, let's say that it looks to me like quarter 3 is always the best seller. Okay, most products sold in quarter 3. Okay, so that explains, that's one comment about that. Part B. In one of these years, quarter 3 was very cloudy. Write down which year it is most likely to be. Give your reason. Okay, right. So I would say it's going to be this year because quarter 3 is the lowest. It goes, usually quarter 3 really spikes, but in 2023 it didn't. Okay, because quarter 3 is lower than usual compared to the other years. Other years. Okay, right, there we go. Oh, there's a part C. Part C says, the manager of the shop says that the value of sales in quarter 4 of 2024 will be £3,100. What assumption has the manager made? Let's have a look. So, one second, I need to look at that again. He said that quarter 4 in 2024 will be £3,100. Okay, so let's have a look here. So let's look at all the quarter 4s. So quarter 4 here is at 2,500. Quarter 4 here is at, let's call that 2,600. Or maybe it's 2,700, I don't know. No, I think it looks like 2,600. Okay, let's say this one's 2,700. He reckons it's going to be 3,100. Well, I guess the assumption that he's made is that it's going to continue to increase. I think that would be a safe statement. Okay, so I think that's all we can really say actually with that one. It's going to continue to increase. Okay, and that's referring to the sales there. So the sales are going to continue to increase. Let's have a look at the mark scheme. I'm not the most confident with part C, but we'll see. So here we go. What have we got here? Make one comment. Okay, they've gone for repeating pattern. They've said, so we went for this one, which is it's acceptable. Highest in quarter 3. There's a bunch of things that you could have. So that was the one that we went for. Part B, 2023. Yep, we got that right. And part C is that the trend pattern will continue. And that's what we said is going to continue to increase. Okay, great. Right, so let's have a look at the next page. So, part of the graph of y equals 2x plus 1 is drawn on this grid. Write down the y-intercept. So the y-intercept is where it crosses the y-axis. So that's here. So that is at 0, 1. But they might just want you to say 1. Okay, so the right y-intercept is 1. The line continues to the right. Will the line pass above, below, or through the point 40, 80? Okay, so the line is y equals 2x plus 1. So when x is 4, let's find out. When x equals 40, y will equal 2 times 40 plus 1. So y will equal 81. So if they've got the line, if we imagine this point here, we've got a point 40, 80 here. Let's call it there. Okay, so that's the point 40, 80. Okay. I shouldn't have drawn that line through it. Here we go, 1 second. So we've got the line 40, 80 here. Point 40, 80 here. Now the line actually goes through point 40, 81. Like this here. So this is what the line does. That's where the point is. So it looks to me like the line goes above the point. Okay, so we can say that. So the line y equals 2x plus 1 will pass above the point 40, 80 because it goes through point 40, 81. Okay, write down the equation of a line that is parallel to y equals 2x plus 1. Parallel just means it's got the same gradient. The gradient is given by the number in front of the x value, the x coefficient we could call it. So we're going to say y equals 2x plus 100. Okay, so any line like that, we could have any number here. We could have 2x plus 3, we could have 2x, we could have 2x minus 20. All of these numbers would be parallel. All of these numbers would give a line that is parallel to this line here. Okay, so let's have a mark of those questions and then we'll move on. So here we go. We've got okay, 1, yep, above, yep, 2x plus k. So they've used k to say that you can have any value there, which is fine. We went for 100, so that's all very well and good. Right, let's have a look at the next page. Okay, so here we go. A number r is 6.2 when rounded to 2 significant figures. A number h is 6.2 when truncated to 1 decimal place. So that means it's not rounded, they've just ignored everything behind it. Write down the possible value of r that will definitely be less than all possible value of h. Interesting. Write down a possible value of r that will definitely be less than all possible values of h. That's quite confusing. I need to read this again. So a number r is rounded to 6.2. Oh, okay, yes, of course. Right, so h has to be greater than or equal to 6.2, okay? This is the thing that's going on with h. It's got to be larger than 6.2 because it's been truncated. So that means h could have been 6.2 anything, okay? So anything that was 6.2, blah, 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 would have gone to h, okay? But r has been rounded to 2 significant figures. So if we think about r being 6.2, well, r could have gone to 6.1 or it could have gone to 6.3 in a different world because it has an error interval. So it has the midpoints here. So if we think about these values, 6.15 and 6.25, all of these numbers here went to 6.2, okay? So all of the numbers between 6.15 and 6.25, when rounded to 2 significant figures, go to 6.2. So there are going to be all the values here on this side. Where's the highlighter? There we go. All the values on this side of 6.2 could be values of r, but will be values that are less than, could be values, are values of r that could be values of r that will definitely be less than values of h, okay? So what we're looking at here is we could have 6.17, okay? So R could have equaled 6.17, but H could never have equaled 6.17. So we know that 6.17 will definitely be less than H. Okay, B. Write down a possible value of H that will definitely be greater than all the values of R. So H could have been 6 point anything. So let's say H was 6.29, okay? There was no way that R ever could have been 6.29. So that's what we've got there. Right. Write down all the possible values of R and a possible value of H such that R is greater than H. Let's try that again. Write down a possible value of R and a possible value of H such that R is greater than H. So let's say R was 6.24 and H was 6.21. There we go. Right, let's have a look at that there. That was a funny old question. Okay, so here we go. Any value where R is greater than 6.15 but less than 6.2. Wonderful. Any value where H is greater than 6.25 and less than 6.3. Wonderful. Any pair of values where this is true. Yeah, that's all fine. Right. Okay, I just need to pop away for a second. I will be right back, but you can have a think about this question and I'll see you soon. Okie dokie, right, let's take a look at this next question here. So what I've got here is it says a restaurant menu has 4 main courses and 3 side dishes for their meal. Each customer chooses one main and one side. Okay, so the main courses, here we go, we've got these things here, and the side dishes, we've got these things here. Work out a percentage of possible meals that cost less than £8. Okay, so let's just work out the combinations first. So we've got burger salad, okay, we've got burger chips, and we've got burger garlic. Then we've got lasagna salad. Well, let me make some space here because I want to write some information under that here. So lasagna salad, lasagna chips, lasagna garlic. Then we've got veggie salad, veggie chips, veggie garlic. And then we've got turkey salad, turkey chips, and turkey garlic. Okay, right. Now what we're going to do is let's just work out the prices of each of these. So burger salad would be £8. Burger chips would be £9. Burger garlic would be £7. Lasagna salad would be £9. Lasagna chips would be £10. Lasagna garlic bread would be £8. Veggie salad would be £7. Veggie chips would be £8. Veggie garlic would be £6. Okay, and then we've got this one again, and these will be the same, so that's going to be 8, 9, 7. Okay, right, so how many of these are, what's the question, that cost less than £8? So they only want the ones that cost less than £8. So that is just these ones here. Have I missed any? We've got 1, 2, 3, 4 meals there. So we've got 4 meals costing less than 4 options that cost less than £8. And how many options are there altogether? There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So that's 4 out of 12. And do they want that as a percentage? So 4 out of 12. So to turn that into a percentage, we'll do 4 divided by 12, and then we'll just multiply that by 100. And I'm being really lazy here. I'm going to do that on my calculator. So here we go. 4 divided by 12 equals 0.33 multiplied by 100 will be 33%. Okay, there we go. So we'll call that 33%. And that's to the nearest percent, to nearest whole. Okay, right. Let's have a look to see if that was correct and see what they said. Yep, 33% or 33.3%. Yeah, that's perfect. Right, let's have a look at the next question. So the next thing we've got here is question 25, and it tells us the weight, a sheet of A4 card weighs 1.19 times 10 to the negative 2. Work out the weight of 500 sheets of A4 card. Okie dokie, right, well, this is basically we're just going to do 500 multiplied by the weight of the sheet of card. So 500 multiplied by 1.19 times 10 to the negative 2. Okay, and we can do this all on your calculator using the scientific functions. So let's have a look at what that will look like here. So scientific calculator. So here we go. We have got 500 multiplied by, here we go, 1.19 times 10 to the power of minus 2. And then close the power like that. And this should give us the answer. There we go. 5.95 kg. Right, let's have a look at part B. One sec, let's move that away. So part B says a card is classified using W, the weight in grams per square metre GSM. W equals the weight in grams divided by the area in square metres. A sheet of A4 card is a rectangle that is 21 centimetres by 29.7 centimetres. Calculate W for this card. Okay, right, so we need to find out, do we have the weight in grams? The weight in grams was given at the start, okay. No, it wasn't given at the start. We've got the weight in kilograms at the start, okay. So we need to get the weight in grams and we need to get the area in square meters, okay. So let's first of all think about the weight in grams. So the weight in kilograms is 1.19 times, what was that? 10 to the minus 2, okay, times 10 to the minus 2. So let's just work out what this is, okay. So, and then we can think about converting this into kilograms. So we've got here scientific calculator again. Scientific 1.19 times 10 to the minus 2. So that equals 0.011 kg. Okay, so it equals 0.0119 kg. Okay. So, oh no. Sorry about that. So here we go. We've got yeah, so that's what we've got here. So let's move that back over here. Right, so we've got 1.19 times 10 to the negative 2 equals okay, right, so we've got 0.119 times 10 to the minus kilograms. Okay, so this is what we've got here. Now we know that 1 kg equals 1,000 grams. Okay, so we need to find out what 0.0119 kg is. Okay, so we need to multiply this by 0.0119, and that will tell us how many grams this is. Okay, so let's do that here. So we've got, right, we've got 1,000 multiplied by 0.0199. So here we go. This is 19.9 grams. Okay, right, so we now have the weight of the sheet of paper in grams. So there we go. So this is going to equal our weight in grams. It's going to be 19.9. The next bit we need to do is our area in square meters. So currently these are in centimeters, so we just need to turn them into meters first before we find out the area of the page. So 21 centimeters, well, 100 centimeters makes up a meter. So 21 centimeters is 0.21 meters, and 29.7 centimeters is 0.297 meters. So there we go. We just need to, and then if we multiply those together, we're going to find the area of this sheet of paper in square meters. Okay, because this is a rectangle, length times width. So here we go, 0.21 multiplied by 0.297. So here we go. So this is 0.06237 meters squared, and I'll put that on the bottom here. 0.6237 on the bottom. So there we go. So our W is going to equal 19.9 divided by 0.06237, and then we can just work this out here. So we've got 19.9 divided by 0.06237. There we go, and that equals 319 even. Okay, at 0.1, let's say. So there we go, we can give our answer there at the bottom, 319.1, and we'll just say that's to 1 dp. And that's fine. Okay, right, so let's have a look at that. Okay, and see how we got on. So part A is correct, 595, and then part B, oh, they've got a very different answer. Now, where have they got their answer? Oh, no. Oh, that's sad. Right, I'll show you where we went wrong. It's a very small mistake, but it's carried it through. I did 1,000 times 0.0119 is 19.9 grams, where I should have put 11.9 grams. Okay, so but that's a very easy fix. I can alter that here as well. I'll just highlight all of that, and I'm going to change those in red. So this should have been 11.9, and this should have been 11.9. So let's then do it again to check that we've got that right. 11.9 divided by 0.6237, and that should, oh no, 1 second, I've gone wrong again. Right, 11.9 divided by 0.06237, and that equals 190.8. Okay, I believe that is actually what they got. So let's just put a line through that, 190.8 to 1 dp. And let's check again to see if we now agree. Yeah, there we go. 109. Well, they've put 190.7 to 190.8 or 190.1. Okay, so we're all happy with that. Okay, great. Right, let's have a look at the next page. I think we're probably 22 of 24, so we're getting there. well done if you're still working with me. Thank you for joining me for so long, actually. If you have been watching and you haven't yet liked the video, if you could do that, that'd be lovely. But otherwise, thank you very much. The area of this rectangle can be written as ax squared plus bx minus 10. Find the values of a, b and c. Show you're working out. Okay, right. So it's the area of a rectangle. So the area of a rectangle is length times width. So we've got the two measurements here. So we're going to have x plus c, bracket, bracket, over here. And we're going to have 3x plus 2. Okay, so let's now multiply these out things here. So we've got x times 3x will give us 3x squared. X times 2 will give us plus 2x. C times 3x will give us plus 3cx. C times 2 will give us plus 2c. Okay, and now what we can do is we can compare parts of this. So we've got this bit here, 3x squared will be the ax squared. So we know that a equals 3. 2c will give us the minus 10. So if we know that 2c equals minus 10, that means c must equal minus 5. Okay, so we've got here c equals minus 5. And then we've got the funny bit here in the middle. Okay, so we know that 2x plus 3cx, well, that's going to have to match up with the bx. But we do now know that c equals minus 5. So this is like 2x plus 3 lots of minus 5. Well, 3 times minus 5 is minus 15. So we've got 2x plus negative 15x will equal negative 13x. So that means that bx is negative 13x. So b will have to equal negative 13. So we can then write these all down here. Here we go. So A, and that's the last question. Right, so A is 3, B is minus 13, and C is minus 5. Right, let's quickly mark those. And then if you've got any questions, now's a great time to ask, and we can go through some of the topics. Otherwise, thank you so much for sticking with me this long. And yeah, that's been really nice. Right, let's find the marks for these. 3, negative 13, negative 5. Perfect. Right. Okay. So, yeah, well, there we go. I hope that's been helpful. If you do have any questions, I'll give you a couple more minutes to write them down. If not, I'll just go. But yeah, well done. Thank you so much. Out of interest, is anyone taking their a November resit? Yeah, no. Okay, cool. Well, I will leave it there. Thank you so much for joining me, and hopefully see you in another tutorial. And good luck with your exams or whatever it is that you're working towards at this stage.